Climate change, energy use, and government policy are obviously related, although the latter not as logically as we would hope. The global climate situation, it's hard for the public to recognize. I mean, we've got great weather. It's hard to recognize that we have a crisis. The reason that that can be is because of the great inertia of the climate system. We're changing the composition of the atmosphere very rapidly and a lot. And there are going to be consequences of that. But it takes time for those to occur because of the ocean is 4 kilometers deep, the ice sheets are thick. They don't respond quickly. So our planet is now out of energy balance. We reduce the heat going out to space by putting this blanket of greenhouse gases. And so there's more energy coming in than going out. And so there's more warming in the pipeline. And our climate system happens to be dominated by amplifying feedbacks. As the planet gets warmer, then some more gases, methane and nitrous oxide, and CO2 come out of the system. So there's a danger that we hand young people a system that's out of their control. The planet is getting warmer. It's warmed more than 1 degree Celsius in the last century, most of it in the last 40 years. Almost twice as much over land as over ocean. And that's a significant amount already. In the last 11,000 years, the Holocene, the period in which civilization developed, the maximum temperature several thousand years ago was about 0.5 degree Celsius warmer than pre-industrial. It had been cooling off the last several thousand years. But now with this rapid warming in the last century, we're well outside the range of the Holocene. And we're approximately at the temperature of the Eemian, which is the prior warm period, the prior interglacial period 120,000 years ago, when it was about 1 degree Celsius above pre-industrial. So we're approximately matching that now. And that will eventually have consequences. During the Eemian, sea level reached heights 6 to 9 meters, that's 20 to 30 feet higher than today. Now, if we just left the temperature at today's temperature, it might take quite a while before that sea level would rise many meters. It may take millennia. However, we're not leaving the temperature at today's level. It's continuing to go higher. And we published a paper 2 years ago which argued that if we stay on business as usual, we'll get multi-meter sea level rise in 50 to 150 years, which would mean that we would lose functionality of most coastal cities. And more than half of the large cities in the world are on coastlines. So we really can't let that happen. We can't will that situation to young people. That's one of the irreversible climate impacts. The other irreversible thing is extermination of species. We're putting stresses on different species in many different ways, but in combination with shifting climate zones, that has the potential to drive a significant fraction of the species on the planet to extinction. The climate zones are moving at a rate of about 5 to 10 kilometers a year. And and many species can't migrate that rapidly. One of the better examples is the coral reefs, which harbor millions of species. And they are under stress for a number of reasons, things that we're doing, but especially because of the warming ocean, which causes the coral to expel their symbiotic algae and die during the hottest periods, especially El Niños. And also the ocean is becoming more acid. So those animals that have an carbonate skeletons will suffer and eventually dissolve if we continue to make the ocean more and more acid. In addition to those irreversible effects, we're beginning to see practical impacts due to the fact that the climate is naturally variable. The temperature, this is showing a bell curve for the natural variability that existed 50 years ago, where some summers were warmer than average and some were cooler than average, and you get this nice bell curve distribution. But over the land areas, you can see that in the summer, that bell curve has shifted significantly. There are still some summers that are cooler than the average 50 years ago, but most summers are now warmer than the long-term average, and some of them are extremely warm. And so in places like middle latitudes, Canada or the United States or Europe, the shift is beginning to be noticeable in the summer. It's only, it looks like about 1 standard deviation in the summers, so not so noticeable. And in the winter, it's even harder to notice that there's a change. But other places on the planet, in the subtropics in the summer, like the Middle East and the Mediterranean region and the Southwest United States, the shift is more than 2 standard deviations, so that every summer is warmer than the average 50 years ago. And it's becoming uncomfortable in the summer in those places. And in the tropics, it's significantly warmer in all 4 seasons, which is making it difficult to work outdoors. And more than half the jobs are either agriculture or construction, and they're outdoor jobs. So if we stay on this path, it's going to be unpleasant to live in those places. It's going to encourage migration out of those places to higher latitudes. This is leading to an increase in the climate extremes locally and regionally. So the increased heat gives you more extreme heat waves and droughts and fires associated with those. But at the same time, because you get increased evaporation from the ocean, at the times and places you get rainfall, it comes down in more extreme events. So the 100-year flood occurs more than once a century. We're moving in the direction of having these 2 extremes, either too hot or too wet, too dry or too wet. So as people finally begin to notice that something is happening, by that time it may be too late. And there are a number of potential injustices associated with this. One of them is, of course, today's generation is getting the benefits of burning fossil fuels, and the consequences are going to be felt mainly by young people and their children. There's also this north to south. It's the developed world that's burning the fossil fuels, and the developing world, most of which is at lower latitudes, is actually getting more consequences than we in the north. And also, of course, humans are causing the whole problem, and all the other species are paying a price. So what's happening, we've recognized this way back in 1992 with the Framework Convention on Climate Change. We decided we should avoid dangerous human-made climate change, but that requires reducing our fossil fuel emissions, but in fact they've continued to go up. In the developed world, they've sort of flattened out, partly because we've moved production of a lot of our materials to the developing world. So in the United States, for example, the thing is we're getting most of our energy from fossil fuels. We're subsidizing heavily renewable energies, but they still provide only a few percent of our total energy. In Canada, well, you have a lot of hydropower, but your emissions are not going down. In fact, if you look at per capita emissions, Australia has passed the United States, and Canada is growing. I mean, you're almost as bad as we are in the U.S. on a per capita emissions. And of course, the rest of the world, that's where the big increases are coming, because we used fossil fuels to raise our standard of living, and they want to do the same thing, and they have every right to do that. And if they don't have alternatives, they're going to do it the same way that we did, and that's burning fossil fuels, and that's what they're doing. In a paper we published last year, Young People's Burden, we show that unless we begin to reduce emissions very rapidly, we're handing young people a situation where they can only stabilize climate by sucking CO2 out of the atmosphere. And we show that the cost of that, if we stay on business as usual, is going to be in the hundreds of trillions of dollars with any of the technologies that we know about. And that's just implausible. So we're in danger of handing them a situation where there's really no, doesn't appear to be any way out. And the tragedy of this situation is it's not necessary. You know, if we would, so we looked in that paper, we show different scenarios for the future, continuing emissions increase. Oop, I didn't mean to do that. Can I go backward? What I meant to do was push this. So continuing business as usual, or flattening out emissions, or decreasing emissions 3% a year or 6% a year. If you would reduce emissions 3% a year, then the warming would peak at less than 1.5 degrees and then slowly decline, even without sucking CO2 out of the atmosphere. So it's still physically possible to stop further warming, but it requires beginning to reduce emissions. And the problem is that fossil fuels are the cheapest energy. They appear to be cheapest because they don't include their cost to society. Just the cost of air pollution on human health, if you would only include that, you would make the competing cleaner energies much more competitive. And instead, we're even subsidizing the fossil fuels. So the solution that's required is make the price of fossil fuels honest by including their cost to society. And you could do that in a very simple way. Just collect the money from the small number of sources, the domestic mines and the ports of entry. So it costs almost nothing to collect it. And if you would give that money to the public, an equal amount to all legal residents of the country, then most people would come out ahead, about 70% with the present distribution of energy use. And that would, and we could move rapidly on that 3% per year reduction rate. In fact, the economic studies show that if you had a $10 a ton carbon fee rising $10 a ton each year, by the end of 10 years, the emissions would go down 30%, which is more rapid than 3% per year. But you have to actually do that. You can't do it with some gimmicky thing like cap and trade, which does almost nothing in practice. Globally, it doesn't do anything. The emissions just continue to go up. So this, by the way, is the only viable international solution. We've tried the cap and trade route, the Kyoto Protocol. It doesn't do anything. But if the United States or Europe or China would decide to have a across-the-board rising carbon fee, they can impose that practically globally by means of saying we're going to put border duties on products from countries that don't have an equivalent carbon fee. That's an enormous incentive for those other countries to have their own fee so they can collect the money themselves rather than have us collect money at the border. Economists say that would work, but politicians don't want to do it that way. By the way, there's an organization in the United States and in Canada called Citizens Climate Lobby that's supporting exactly this kind of solution. And, you know, they're trying to use the democratic process. They write letters to the editor, they visit the Congress people, the representatives, and try to argue for a carbon fee and dividend. I think on a per capita basis that Canada has, in the United States there are now 90,000 people in this organization, and they're really beginning to be heard in our government. Are there any people from Citizens Climate Lobby here? Oh, we have at least 4 people, 5, 6, 7 people. So, if actually more than that. So there are quite a. So if you if you're interested, this I think is the single most important, most effective thing that a citizen can do is to try to use the democratic process to force our government to do something sensible. As Margaret Mead said, a small group of thoughtful, concerned citizens can really change the world. In fact, that's the only way we ever do it. And in the U.S., you know, the conservatives, the true conservatives, actually like this kind of approach because you're using the market to help you do something sensible. And economists will tell you that making prices honest is the best way, is the most economically efficient way to deal with something. But we've got to put pressure on the government. So in addition to trying to talk sense into them, we also filing a lawsuit against the Trump government and we have now finally been granted a trial date in this October. And I'm very confident we're going to that we are going to win this case at the U.S. District Court level, which will then no doubt get appealed to the. But I even think that at the Supreme Court level, that the basis for this, the constitutional basis for this, that young people are people, and we're depriving them of life, liberty, and property without due process of law. I think that we will win this, but it's not enough. Courts cannot impose a solution. They can just tell the government it's got to have a plan. And that plan, we don't want the government to go through a bunch of half-assed plans like cap and trade. We want something that will work. And we don't have a lot of time to go through things that don't work. You know, in 1981, after we published our first major paper on this, I organized with Taro Takahashi a symposium at Lamont Geophysical Observatory in Palisades, New York, where the after-dinner speaker was E.E. David Jr. of Exxon Research and Engineering. And he said he correctly identified the characteristic of this system. That is that when you have a system in which the response is long delayed and you have these amplifying feedbacks, it's a very dangerous system because you can lose control of the system unless you have anticipation. Well, the required anticipation would have been developing energies that don't produce CO2. Instead, what ExxonMobil decided to do, along with the other oil majors, was develop fracking. And it took them decades to perfect it, but they did. And now that just compounds the problem. One of my grandsons, Connor, was a big Indiana Jones fan. In fact, he's the one who introduced me to these hats. He first gave me an Indiana Jones hat. But he correctly, at age 10 years, correctly identified a couple of key points. One is, he said, unless we can figure out how to make a time machine that actually works, we're not going to be able to go back in time. We're not going to be able to fix this problem. And he also said, well, grown-ups are scared of nuclear power, but what about fossil fuels? Shouldn't we be scared of fossil fuels? They're not safe. They're very dangerous. We always get this statement that, well, nuclear power would be nice, except it takes forever to build a nuclear power plant, and you can put up a solar panel quickly. In fact, the fastest introduction of power has been as hydro and nuclear. But those were when, if you first have a spin-up time, you have to decide you're going to do it. You have to have the R&D so that you're ready to begin to build plants. And we had decided, we don't need. Jimmy Carter and Bill Clinton in the United States eliminated research and development on advanced generation nuclear power. So that it's not really ready, although we've got a lot of startup companies that are trying to do much improved nuclear power, which we should have been doing the R&D on. 3.5 million people a year die from indoor air pollution. That's about 10,000 a day. And the kind of things you get from that, like lung cancer, are very unpleasant ways to die. As Michael mentioned, thyroid cancer is not as bad as that. But anyway, you don't need to get any of those cancers. But the thing is, we shouldn't be so irrational about this. We have to look at the science rationally, and then we should be not making decisions for young people which they're going to have to live with. We should at least give them some alternatives. And this was just one example of a kind of technology. So, I'm actually grateful for Canada. You actually have a nuclear regulatory commission that functions as a nuclear regulatory commission. In the United States, we have one that functions as an anti-nuclear organization that's trying to phase out nuclear power. That has just become a political organization in much of its existence. It costs so much money, and so many. Now, some of the startup companies give them plans, and they say, come back in 42 months. We'll have looked at your plans. And also give us $100 million to evaluate your plan. I guess that was the end of it. Thanks.